All right. So this is the first thing that we have to explore. Once we have already checked for the quality of the data set, remember that I mentioned looking for missing data or outliers, looking into the distribution of the data. All right. So before we look ahead to predicting a value of y by using a value of x, here y being your dependent variable that you may choose with reason, and your x, your independent variable or predictor that you also choose with reason, we need to first establish that we have a legitimate reason to predict, as I say, one value of I given a value of x by using a straight line. Okay, that is the nature of the linear regression. And we also need to feel confident that using a line to make that prediction will work well. In order to achieve these essential steps, we will plot first the data in pairwise fashion, okay, 1-to-1. Even if we have 2, 3, 4, or any amount of predictors, if they are quantitative and if they are continuous, we will plot them all of them against the dependent variable in a pairwise fashion. Okay. Then once we do that we can do with scatter plots, okay, in Jamovi. So we have the data that is continuous. We go to exploration, scatter plots. We put our dependent variable in the x-axis. Our independent variable in the x-axis, our dependent variable in the y-axis, and we plot the scatter plot. So here, it's rather obvious that the relationship is linear. Okay. So after that, we have to quantify that relationship, right? The scatter plot is a rather qualitative observation that's necessary. You have to do it, but it's not quantitative. Okay. So with Jamovi, we have the data. Remember that you have to have this ruler if you want the data to be considered continuous. That should be by default if you have decimal points and so on, or if the data looks like this. Go to scatter plot, assign the variables to the proper fields. Draw the scatter plot. We may draw a line. This is just a thing that we can do. It's not really relevant because we don't have information about this line in this particular tool, in the scatter plot tool. But now that we are convinced that the relationship of these two variables, and we can do this for any two variables that are continuous, we can use the correlation matrix tool inside the regression tool set in analysis. We populate the right-hand box of correlation matrix with any number of variables that we want to explore their correlation. Makes sense. And the thing that we will have by default selected is Pearson's R and significance of that statistic. So this is the result of that correlation matrix. We will have only one useful cell here because we only have one comparison. And this is clicks per month versus watch time. And the correlation is 0.82, which is positive. and strong, given the value. So this would be a table for qualitatively assessing what a given number means. Also, totally subjective and dependent on your field. Now, the p-value is the probability of that correlation. It's under the null hypothesis that there's no correlation. This p-value is the probability of observing this number or one more extreme, okay? Taking into account that Pearson's R can go from -1 to 1 for negative and positive correlations. So with this number, with these two numbers, our interpretation is that there is a strong linear correlation between these two continuous variables. We can only assert this after first drawing the scatter plot and then using the correlation matrix. Okay, you can have high Pearson correlation coefficients for two variables that are not linearly correlated, and that's something that it's inconvenience of Pearson's R. That's why you do the plot. So after we have a handle on which X variable may be related to a Y, to the dependent variable in a linear way, we try to find which is the straight line that best fits the data. Okay, the things that define a line are a slope and an intercept. And because we only have one independent variable, the formula of that line will be a plus bx. Okay, and you will see this now. So to get this linear regression, we can use the tool in analysis, regression, linear regression. So analysis, regression, linear regression. We drag and drop the outcome variable to the dependent variable field and the predictor variable to the covariates. Okay, here factors would be qualitative variables. All right, if we had information about the gender, group age, any type of information that wouldn't be continuous, we could put here in factors. All right, it would have similar analysis after this. So the result that it's this this group of tables is shown in the right hand of the panel once you do this. And the default results include the R, which is the same as the Pearson's R, and R squared, which is known as the coefficient of determination, which is a statistical measure in the regression model that determines the proportion of variance in the dependent variable. So the variance, how this dependent variable is distributed around its central point, that can be explained by the independent variable. Okay, so it's also a measure of how well our data fit the regression model. Although this sentence, it's the other way around. So we want our model to fit the data and not the data to fit the model. So sorry about that. It's how the regression model fits the data. All right. So R, Pearson correlation coefficient, R squared, coefficient of determination, the percentage of the variance in the dependent variable that it's explained by the independent variable. Most importantly, these results give us the model coefficients, which in this case are just the two, intercept and watch time. Okay, In this case, in this table, we didn't ask for any type of confidence interval, but you should know that every estimate that you will have has an uncertainty that can be assessed with 95 any percentage of confidence. Okay. So with two continuous variables, the result of this simple linear regression comes in the general form of y equals a plus bx, okay, where a is the intercept and b is the slope of that line that best fits the data. So now we can make estimates by using this regression line. Okay, so we have a formula. We can plug values of x, and we can estimate the average value of that y for that given value of x. Here it says the average, because remember, this number here, the estimate, it's just a central value within the 95% confidence interval. Well, within any size confidence interval. So the basic idea is to take a reasonable value of x, plug it into the equation of the regression line, and see what the value of y gives us. Okay. Consider that you can only do this for values of x that are within the range of values of your independent variable that you used to create that line. Otherwise, you will be extrapolating, and it's kind of a no-no in linear regression. Okay, so the only things that you can do safely is using values of x that are within the range of values that the independent variable has that you used to create that regression line. What are the conditions for a good model? The residuals must have a normal distribution with mean 0. And we can explore that with the option normality test assumption checks. Here we have the option of normality test. So with this test, the null hypothesis is that the data are normally distributed. The data here being the residuals, and the alternative is that they are not normally distributed. Okay, so with a p-value higher than our significant threshold, that can be any number, usually 0.05, we can't discard the null hypothesis. We cannot discard the null hypothesis. Hence, we are satisfied with the normality of these residuals. Moreover, with residual plots, we can explore the variance of the residuals. That should be homogeneous. Okay, so this is the plot that I'm talking about. And with this data, we have some issues for low values of x. And that is something that is artificial for the way in which I simulated this data. Otherwise, this is a reasonable plot to observe the homogeneity of the variance and the independence of these residuals from each other, meaning that you don't see any pattern here. If you saw a curve or anything that's not just a cloud, may point out that our linear approach is not the best idea. Okay, those would be the residual plots. The residual plots plot the distance for any given data point to the linear regression. Okay, They certainly should be centered at 0. Okay. Now, the idea of regression is to build a model that estimates or predicts one quantitative variable, y. This is in the case of simple linear regression, by using at least one other quantitative variable, x. Simple linear regression uses exactly one variable. This is from the book. I got this information, sorry. Multiple linear regression, on the other hand, uses more than one x variable to estimate the value of y. Okay, so but multiple linear regression, it's basically the same set of ideas. Okay, it's just that the formula, it's a bit more extent, that the formula of that line that we draw. Okay, so the steps to follow to create a multiple linear regression model are the following. You go through your data and decide and assess and guess which are the possible x variables, so dependent variables, that may be helpful in estimating y. You collect the data on the y variable and the x variable that you deemed appropriate. Check the relationships between each other, okay, using scatter plots and correlations. Okay, correlations here stands for the correlation matrix, and use those results to eliminate those that aren't strongly related to the outcome variable. Okay. Then you look at possible relationships between the predictor variables. So you check that they are not redundant. This is the same to say that you're looking for problems of multicollinearity. Okay. The idea is that if two predictor variables are related with each other and relate in the same way to the outcome variable, you don't need them both. And if you had them both, you will have trouble assigning the proper parameters to those variables. Okay. Well, this maybe should be 1, 2, 3, 4. We use those variables from step D in a multiple regression analysis to find the best fitting model for your data. Okay, and that is what we're going to do next. And we use the best fitting model in step E to predict y for given variables, for given values of x, by plugging those into the model. Okay, so when building a multiple regression model, we can have various approaches, but one way of doing it is adding one variable at a time. You can at least see two obvious ways of doing it. One is one variable at a time, starting from 0 variables, or alternatively, using all variables and then removing one after the other to see if the model improves when removing variables. Okay. So there is a data set in Jamovi called Parenthood that you can find if you go to Jamovi Open Data Library and Parenthood. This is a built-in database that you can use to exercise this set of ideas. Okay, so we need to be sure that this is understood before we move forward. So if you have questions, please ask. But if you don't, please go into the parenthood dataset and try to perform this analysis. Okay, I'm going to open it too, and I'm going to explain you what the variables are. But I'm expecting you to do this by yourselves. All right. Now give me just 1 second. All right. So if you go to open data library and learning statistics with Jamovi, this is where you should find a number of datasets to work and learn with Jamovi, but parenthood is one of them. Probably you stopped saying it. Sorry, give me a second. Okay, so basically here we have a very simple dataset to explore these ideas, where we have hours of sleep of a parent, hours of sleep of a baby, and the mood of the parent in question. Okay, so if you were able to open this dataset, you're welcome to perform this regression analysis to explore the relationships within these variables. And you're welcome to ask questions, of course.
Jorge, em demanen si pots repetir com agafar la dataset.
Sí. Sorry. You should find it here in this menu with the 3 lines. Open, and you should see this PC and data library. Everyone sees this? And please, unless you don't have microphones, please speak out loud, because it really does feel that I'm talking to the void here. So, and I can't see the chat, so please speak out loud. Here, you should have data library, and you should have here a folder called Learning Statistics with Jamovi. Do you have this?
Yes.
Okay. So if you do, you click Learning Statistics with Jamovi, and here on the search field, just type parenthood, and if you click on it, you just will be able to open this data set. Okay?
Okay, thank you very much.
Thank you.
Podries explicar la dataset perquè si no, no crec que et segueixin,
Doncs, bueno, sí, però repetiré el que he dit. Aquí tenim la primera columna. Sorry. Sorry. Here we have done sleep, which is the hours of sleep of the parent. Here we have baby sleep, which is baby sleep hours.
Excuse me, Jorge.
Yep.
Yeah, I don't find the parenthood in.
Parent is not here.
All right.
Yeah, it's not here. I just have 4 files, I think, no more.
Okay,
Yeah,
so
you have four, yeah.
all right. So if you don't have that, go to modules here on the top right, Jamovi library.
Okay.
Yeah.
And then you should scroll down until you can see LSJ dash data learning statistics with Jamovi. And if you have that installed, you should have it. And if you don't have it installed, you should have a button that says install. And then you can install that dataset. Do you have it installed or not installed?
Right. Just give me 1 minute. Hold on.
Yep.
Yeah, we need some time as well. So we have to go to the module, like where? Like again?
Modules, Jamovi library.
Oh, Jamovi.
And then you scroll down. You cannot search it. You just have to scroll down to learning statistics with Jamovi. And then if it's not installed, you should have a button that says install.
Perdona, Jorge, ¿dónde has
Ya.
ido a la librería para instalarlo? Que justo estaba escribiendo al chat y no lo he visto.
Okay. You go to the top right corner where it says modules. You can see my screen, right? Is it large enough?
Sí, perfecto.
Okay. So you go to modules, Jamovi library, and you will start at the top. So you need to scroll down until you see LSJ data, learning statistics with Jamovi. And if you don't have it installed, my understanding is that this was installed by default, but maybe it's not. So if you don't have it installed, you should have a button that says install. And then you click on it.
Ok, gracias.
You're welcome. Okay, so I give you some minutes so everyone has it.
I already downloaded, but I continue just looking for files.
So
Sorry.
here
I don't know
in
what happened.
open data library.
Yep. Yeah. It's I just have the
You have
same
this?
4 files.
You don't have this folder that says learning statistics with Jamovi.
No, same here. The
No.
same 4
Same.
files, and I already installed like everything that you say.
Okay, could you refresh your Jamovi? Just shut down Jamovi and open it again then, because this is what you downloaded, so it should be there probably.
All right.
And if it's not, I will just send it through David. Yeah, but that's why I picked this, because it was already with Jamovi, so we didn't have sending issues. But let's see if we succeed.
Already. Yep.
It's there?
I have one folder. Oh. And what's the name of the file? Sorry, parents. What?
Parenthood.
Parenthood. Okay, let me check. Yeah.
Yep. Cool.
Great. I already. Thank you very much.
You're welcome. So if you have it, the first column is the parent sleep hours. Sorry. This is parent sleep hours. Then baby sleep is baby sleep hours. Dan Grump is the parent's mood. And day is just the day. So now you have this data set.
Excuse me.
Yeah.
Could you repeat? I was.
Yes, certainly.
Excuse me.
So Dan sleep is the parent's sleep hours. Okay. Number. Yeah, in hours. You don't have to type this. I'm just typing it for you, but this is just a description. Just don't change the name of the variable, or do it. It doesn't really matter. Baby sleep is the baby's sleep hours, and then grump is the parent's mood. Grump it's a shorthand for grumpiness. So the higher it is, the grumpier is the parent. So you can have a guess as to how baby sleep, Dan sleep, and grumpiness should be related. Okay. And what you can do here is first off, notice that grumpiness perhaps should be considered continuous, not just nominal, so continuous. And well, it's up to you to decide what should be here a predictor or an observable, and or a dependent variable. But it's part of the exploration. So the idea is that you explore this with the tools that we discussed yesterday and earlier today, and let's see what you can come up with. All right? Everyone understands the idea? No one understands the idea?
Yes, yes.
All right, thank you.
Sorry, Jorge, I got lost with that we had to do. Could you repeat, please, what the?
Yes. So you have a set of data. Yes. And okay, let me share something different. Yeah. Okay, let us see. So before before looking ahead into making any type of predictions about anything regarding to a data set, we have to first establish that we have a legitimate reason to do so. And because the tool that we are going by now is linear regression model, we have to establish that it's legitimate to use a straight line to do our analysis. And to do so, the first essential step is to plot the data in a pairwise fashion. So we can visually look for a relationship. So
no es veu, és molt petit.
No es veu?
Sí, no sé si pots fer l'exercici i guiar-los directament des d'allà mòbil.
Sorry, this, like this?
Sí,
Sorry.
ara es veu.
Okay. But do they? I thought the students had this file. David, do they have it?
Suposo que sí, però clar, t'estem seguint de veure, si no.
Yeah. Okay. So, in order to achieve the essential step of establishing that there's a legitimate reason to use a straight line to study the relationship between variables, we need to first plot the data in a pairwise fashion, so we can visually look for relationships, for a relationship. Okay. So to do that, we do scatter plots. So we have the data in the data set. We go to exploration, scatter plot. In scatter plot, we assign what we want to be the x-axis, what we want to be the y-axis, and look at it. If you think that a straight line can be a good summary of those points of that cloud, then you go to the next step, which is the correlation matrix. All right, so you do that for the variables that you have in the data set. In the correlation matrix, you can do it all at once. So you move all your variables from the left box to the right box, and you will have, by default, the Pearson correlation coefficient and the significance for that coefficient in a table that will look like this, probably larger because you have more variables. Now, you have to see if that correlation is relevant at all and if it's significant. So these are a table for what are negligible, weak, moderate, strong, or very strong correlations, okay? But this is very subjective. And you see the value of the p-value, which is a measure of the statistical significance of your finding, which is a correlation. This p-value should be low, but particularly should be lower than a threshold. This threshold is arbitrary, and usually it's 0.05. And you should continue with the file, but I feel that this is what I went through the first 30 minutes. So the idea is that you go through this file that you have access to and try to follow these steps with the data that you have in the data set that we just mentioned, parenthood. You will find that you have more than 2 variables. So just you will have just to use a bit of ingenuity that passes that goes with instead of having just 1 covariate, you will probably have 2 covariates, and that's it. And then we can see what is relevant about that regression that you're going to get. All right. I hope that answers the question.
And
Yeah.
must we have to choose just 2 variables to
No.
that, or
you have to choose the variables that you can assess they are linearly correlated. So if there are more than 2 variables that are linearly correlated, you have to have decided which one you think is the response variable. So you have the hours of sleep of the parent, the hours of sleep of the baby, and the mood of the parent. So if you think about causality, if you think about the order of things, what do you think is a response? What do you think is the dependent variable, the thing that depends on the others? Okay, it might be,
okay.
It might not be clear, but you must guess. If you don't guess, you don't have a regression model. So you make a guess, and then in the regression, in the analysis linear regression tool, you put the variable that you think is a dependent variable in the dependent variable field, and the independent variables in the covariates field. Only if you determined that the relationship that those variables have to the dependent variables are linear. And you did that with the scatter plots and the correlation. Yes, well, that is what you have to do. And then you will have a summary of your linear regression, and this is what you're going to see once you have it. All right. Does anyone think they have something, or everyone feels that they cannot move forward, and anyone wants a question? Anyone has a question, or otherwise I will. Yep.
Like the dependent variable, isn't it?
Sorry.
Like baby sleep is dependent variable here. We can consider.
I don't think so.
Okay.
So you think the mood of the parent affects the sleep of the baby, or that the sleep of the baby affects the mood of the parent?
Yeah, I'm sorry. Like the mood actually. Sorry, I thought like the just I said wrong. Like yeah, I mean dependent variable is the mood. It depends. Like sleep is the independent.
Yes.
Yeah. Sorry.
Okay, I let you a couple of more minutes then. So let's say we have no idea. Sorry, there was a question there for a second. No.
Sorry.
All right. Yeah.
I would like to show you if I'm okay.
Sure. Let me stop sharing now.
Okay. Hold on.
Yes. Holding on to dear life.
Okay. I choose here Dan sleep as a independent variable, and Dan grump as dependent variable. Okay.
What do we see here?
Okay. We can see that the grump is affected by the hours of sleep.
How so?
When I have more hours of sleep, grump downs.
Makes sense.
Okay.
I believe. Yes. Okay. So that's a correct interpretation. What is the thing that we get from this? So what were you looking for when you draw this plot?
I think the level of is here. The level of
that is the table.
selection?
But what were you looking for when you did the plot? It's different than the table.
What I see here.
Yeah, so you draw the plot, and also you have a table below. I know, but the plot and the table tell you different things. So my question to you is, what were you looking for when you draw the plot? So you had to draw it, and you did it the proper way. My question is, what is that you were looking for?
Well, it's not the same that I already said that.
No.
When I see here in the plot with where with people chose more hours to sleep, decrease the grump.
But the most important thing, so the most important thing and the thing that you were looking for when you draw the plot is that relationship is linear, because it could have any shape. It could be true. It could be true in a many number of ways, that when people sleep more, they are less grumpy. But it just so happened to be linear, right? But it could have any shape. Okay, so now you draw the plot and you decide that the relationship is linear, because that's the interpretation, and then you do the table. Yeah.
Yeah.
And and what do you see on the table?
Well, this is the thing that I have no understood very well, but with Pearson's coefficient, it's minus 0.9. That is, I think it's very the correlation is very, very statistically meaningful.
No. Okay. So let me correct you there. Okay. You don't. The only. I mean, it is. So you're correct in that it's statistically significant, but not because of the 9, but because of the p-value. Okay. So the Pearson's R tells you the strength of the relation of the correlation between the two variables. The significance, it's given by the p-value. Two different things. So it could be statistically significant and be very weak. It could be statistically significant and, such as this case, be very strong. So there are two things that one should consider when doing any type of statistical test. Is one, what is statistically significant, and two, what is relevant. Okay, so if this Pearson's R was 0.1, the p-value in another scenario, the p-value could be also very, very low, saying that correlation exists, but maybe because it's so weak, you don't care. So that's the difference. So one is, in a way, the strength of the effect or the strength of the correlation, definitely. And the other one is the statistical significance, which the statistical significance tells you the probability of observing that and you being wrong, right? But okay, so it's very low.
Yeah, I understand. I think I have to do more examples to practice with this concept. It's just this concept now. So thank you.
Okay, but this is the first part. Did you get to do a regression?
Okay. Oh, sorry. What did you say?
So this is the very first part of the analysis. So now you at least have that two variables are correlated, but this is not a linear regression, right? So you need to do a linear regression. Does anyone have a linear regression?
Okay.
Thank you for sharing. Thank you for your question. I think it was very instructive.
Thank you, Jorge.
So did anyone manage to get to the linear regression part?
Hi. I think that I have the linear regression. Not sure, but yeah, can I show you?
Please.
Okay, just 1 second. Can you see my screen?
Yes, but now.
Okay. So yeah, I was just like plotting, and yeah, so I see the intercept, and it's still the p-value here. So with these variables, I got this results for the linear regression.
Why don't you click on the linear regression part? So just where you were, so we can see the options that you used. Yeah, if you click there.
Here. Okay.
Yeah, click. Yeah, exactly. Okay. So first thing probably doesn't change anything. I am not sure. But then grumpiness, probably you should set it to continuous variable. So see that you have those 3 balls where it says done grump instead of the ruler. So if you go to the data, so if you go to the columns of the data, yep. And if you can just slide, you need to, no. You need to change done grump to continuous.
Then grump. Okay.
Yeah.
Just 1 second. Let me just squeeze this here. Then grump. And then this goes to continuous, right?
Yeah.
Okay.
All right. So what is the first thing that we see in your model? So what is the model fit? What do we get from model fit?
The model fit shows me that there is a correlation, and the R square shows me that the power of this correlation is close to 1, meaning that is a strong correlation.
Okay, so the R gives you the correlation. Okay, the R squared tells you how well your model explains the data. Okay.
Okay.
So yeah, so R is the same as the Pearson R, is the coefficient, is the correlation, and the R squared is the percentage of the variance in the data that you're trying to explain that you successfully explain with your model. Yeah.
Okay.
And then, so you selected covariates, baby sleep, and Dan sleep. All right. Okay. So, but before we move on, why don't you go to the to the options? If you scroll down, where you are in linear regression, just scroll down and go to model fit. Yeah, scroll down. And for instance, here you would like to have the F test.
Okay.
Which says overall model test. Yes. So that tell you. So that is part of the analysis of variance, and that test gives you a measure of the quality of the model. Importantly, what you would like to find is that the p-value of that test, of the result of that F, is lower than 0.05, which is the standard threshold. Yeah. So that's good.
Yeah.
And then in modern coefficients, you have the intercept, baby sleep, and the slopes, and the parameters for baby sleep and then sleep. So there is something weird there.
Why?
What about those p-values?
Okay, so yeah, the intercept is less than 0.05, and also the parents sleep, but not the babe sleep, right? Okay.
Yeah. So probably we have an issue. So I'm certain that baby sleep affects the grumpiness.
Sleep, yeah.
Yeah, but probably we have a problem of collinearity. Yeah, and you can see there in the collinearity statistics that you created that table. Yeah. So there's moderate correlation between baby sleep and dan sleep. You see that because the BIF, that column.
Because it's the same. Because I thought it interesting that is the same values for both. So is that correct? This is...
Yes, yeah, because it's the value to one another. So it's 165. I see, which is moderate. But basically, if you in the first part of the exercise, if you draw a plot of baby sleep to done sleep, you will see that they are correlated. Okay.
Yeah.
And one of the things that we must do is consider not using predictor variables that are correlated because they are explaining the same thing. All right. So, okay, let me share and let's try to see.
Let me stop.
Yeah.
Let me stop sharing mine. Just 1 second.
All right. So let's see.
Have I stopped sharing mine yet?
Yeah.
Because I can see my screen. Okay.
Yeah. All right. So first things first, we can explore this data in the descriptive fashion. So you can do this with any data set of any size, of any shape and any form. So this is a very small data set, but this is something that you have to do. All right. So in the exploration, you go to descriptives. All right. And this is the step 0. Be familiar with your data. Yes. So here we see baby sleep, done sleep, and done grump, and well, days and ID I believe are rather irrelevant. So we have 100 entries for each one of these variables, 0 missing, and well, we have means and medians. Nothing much that you can get from this, but you can do plots of this data, see if we have outliers or any of the sort. You do not, and just probably as a matter of curiosity, you do histograms, and yeah, but nothing particularly relevant about these histograms. I guess the most important thing is the fact that we don't have outliers. We have all the rows populated, so we have 100 entries for each, and we have no missing data. All right. After that, let's do some scatter plots. So we have some a priori conceptions here, and I think that grumpiness will be affected by baby sleep. Well, it's way too big now. And maybe. So this looks like a line that should go down. It doesn't seem, I mean, there seems to be a lot of variance here, but if I had to guess, I would say that the relationship is linear. All right. I don't see any other shape here. Okay. You can do the same for, so this would be for baby sleep versus grumpiness or vice versa. And you can do this also for grumpiness and this parent sleep. So if you had to guess, just by looking at this, okay, so look at how the points hover around the line that we draw for done sleep as predictor of grumpiness, okay? And now of baby sleep. Okay, so the sleep of the parent probably is a way better explanation of the parent's grumpiness. Yeah, just a priori, just because this graph, or sorry, this plot shows us that these points are way closer to this a priori regression line. Okay, so this is the expression that you do, but you can also see if baby sleep correlates with Dan sleep, and they do. All right. So that might be a problem, that Dan sleep and baby sleep correlate, because those, we want them to be explanatory variables. But if they are correlated, well, we have what's called collinearity, and they would be explaining some of the same effects on the observable variable, and that would take accuracy from our guesses of the parameters associated to the variables. All right. Okay. At any rate, we decide to move forward, and we go to regression. Sorry, not regression, but first correlation. And here we, because it's a matrix, accepts all of our variables, and is grumpiness correlated to Dan sleep? Very much so. Negatively correlated. So the coefficient of correlation is Pearson's R is 0.9 negative. That's a strong or very strong correlation. It is definitely statistically significant because of the value of the p-value. Grumpiness and baby sleep also correlate, but less so. So if we go by the table that I shared with you on that Word document, if I find it, a correlation of 0.57 should be a moderate negative correlation in this case. And also the baby sleep and Dan sleep, or parent sleep, is also correlated, also moderately so, but just a tiny bit higher than baby sleep. The thing is that if I asked you, is this number high? Well, definitely this is positive, yeah, and this is negative, yeah. But are they really different? I told you that we always have uncertainty about any measurement or any guess that we make, or the estimation of any parameter that we make, right? And to see that, we can use the confidence intervals. And if you see here, now we have a range for values that we would be confident about, that contain the true correlation of, in this case, baby sleep and Dan sleep and the others, okay? So in this case, here, it says that the average, or like the central Pearson correlation coefficient is 0.63, right? But if you see the range in which we have confidence of 95%, it's rather large, okay, from 49 to 73, okay? And if we look at Dan grumpiness, we see that we have this negative correlation that goes from 42 to 69, which is also rather large. The thing that
can I interrupt
yeah,
you just for a second, just 1 second? What makes, why do you consider, because like at a first glance, I would not consider a large range, you know, from 63 to 49 to 73. If 63 is in the middle, what would be the parameter there, just for me to have an idea, because it seems not so large to me.
Okay, so so from 49 to 73, yeah. So I just said that as a matter of intuition. I didn't do this calculation, but it's the following one. So this is around 50. Yeah. This is around 70. This is around 70. So we have 20 units there. Yeah. This is around 60. Okay. So we have this 63, it's in the middle of these 20 units. So basically we have the 63 in the middle, and we could have possible values 10 units above and 10 units below. And 10 over 63, it's a rather large ratio. That's that's my guess.
Okay.
Yeah, if the range was, so if this was from 60 to 65, that'd be small.
Okay. Okay.
Well, no, I'm not saying it's bad. I'm saying it's large.
Okay. All right. Yeah, no, just to know,
Okay.
because, to me, it doesn't look that large, but it's good to know that, this is considered large. Okay.
Well, but that's a matter of opinion. Okay. I just told you my reasoning there. But most importantly, besides large or small range of this confidence interval, is the fact that the confidence interval for the negative correlation between Dan grumpiness and baby sleep could also include that strength. You see here that goes from 42 to 69. So it says that the true negative correlation between Dan grumpiness and baby sleep could be minus 0.63. Okay, and that is the same, although positive, that we see in baby sleep to Dan sleep. Okay, so I just wanted to point out that although 0.57 is smaller or weaker than 0.63, once we consider that these numbers have uncertainty, we see that they might not be different at all. Okay, that was the idea. All right. So we have identified correlations. We have identified that they are linear. We want to move forward and go to the linear regression part of the work, which is when we decide that grumpiness is going to be the response. So we go to regression, linear regression, and we say here that baby sleep, dependent variable is Dan grumpiness. And I'm going to go first with Dan sleep. Okay, because it had the larger correlation. So grumpiness, Dan sleep is 0.90. Okay, and then grumpiness, baby sleep is just 0.57. So, okay, going back to the same idea, is 90 larger or stronger than 57? Yes, but most importantly, the uncertainty around 90 goes from 86 to 93, and the uncertainty around 57 goes from 42 to 69. These intervals of confidence do not overlap. Okay, that's a good indication that we are confident in the fact that this 90 is truly different from this 57. Okay. Now, linear regression. We have here the first thing that we see, which is the R, which is the same as a Pearson's R, although, well, in this case, just positive. And we have the R squared, which is the percentage of the variance in the response that our explanatory variables explain in our model. The things that we were looking for are the intercept and the slope. Okay, so well, this slope is negative. The more okay, so the less sleep, the more grumpy this person is. We saw that on the correlation in the scatter plots part. And for both these estimates, there's a test, and the probability of observing those estimates and those estimates actually being 0, which would mean, well, they are not there at all. It's very low. Therefore, we are happy with these values in particular. Okay. Now, if we go to assumption checks, we can see here, for instance, the residual plots. Remember that the residual plots should be homogeneous. So not the residual plots. The residuals should be homogeneous and independent. So just a cloud, no patterns, and that the variance around this 0 is similar at the beginning of the data, at the end of the fit. These residuals should be normal. Okay, so the null hypothesis is that they are normal. Therefore, we do a test. We observe the result that for Shapiro-Wilk, this statistic is in this test is 0.99. So the probability of this data set, of these residuals being normal and observing this statistic is very high. Hence, we can't reject the idea of them being normal. Well, and here we can also do the Cook's distance, which is reasonably low, and well, I wouldn't worry about outliers here. Now, also, well, we didn't see anything. We're also in the correlation plots. But now, let's introduce baby sleep. Okay, so we can do it just like that. And for one, if you look at the R squared, it doesn't improve much, or it doesn't improve at all. The R squared, and the p-value of that estimate associated to the baby sleep statistic parameter is 0.01, and this p-value is super high, meaning that this could be 0. And if this estimate could be 0, means that baby sleep has no effect on grumpiness, or rather, because we already saw that baby sleep and Dan sleep are correlated, maybe all of the things that baby sleep is trying to explain, it's already explained in Dan sleep. All right. If you go to Model Builder, you will see something very useful. You will see blocks. Okay. So these blocks allow you to create different models, so you don't have to swap in and out variables as I was doing. So we can take baby sleep out, add a new block, and add to the block 2 baby sleep. All right. So now I have two models. Okay. I have model 1 and model 2. Okay. Model 1 just has Dan sleep. Yeah. Model 1 just has Dan sleep. Model 2 has Dan sleep and baby sleep. All right. So model 1, this is the data about model 1, and this is the data about model 2. They are basically the same R and R squares. Okay. And if we go to the model comparison, we don't improve the R square at all. We don't improve the overall model fit at all with this F. This is part of an analysis of variance, not on the model. So this p-value tells us that there is no real difference in the predictive capabilities of these two models. So we shouldn't consider using baby sleep because it doesn't improve the model. Okay, so we don't want to add complexity if we don't add predictive capabilities. Yeah. So let's see what happens with days that we totally overlooked days. Okay, so if we go back to exploration scatterplots, let's see if time has something to do with anything. So done sleep. Sorry, let's go with done sleep at y-axis and days as x-axis. Do you see anything here? I don't see anything. Okay, so there's really so the question is, can you draw a line here and say this is the best line that fits this data? I'd say no, but well, you certainly could, but it would be kind of terrible. And what about day and baby sleep? Also terrible. Okay, so this is basically going to say that nothing in particular was happening during this time. Okay, but imagine that we have a larger period of time. Okay, not just 100 days, but we have hundreds of days, even thousands of days. Well, that baby stops being a baby, but probably the sleep patterns of the baby change with time. Okay, maybe the sleep patterns of this baby didn't change within 100 days, but it was worth the exploration. Okay. Are there any questions? Okay, so if there are any questions, I think it's
yeah.
Okay. Go ahead.
I have a question. Like, sometimes we do F test. Like, why we do that F test, or what does that mean? Like,
Yeah.
we have like 300 something or 1000 something. I mean, what does that mean? Like, if it's 300, if it's 1000.
Yeah.
Thank you.
So that F is the result of an analysis of variance that Jamovi does on the results, but on the regression line in relation to the variance of the data. Okay, but this is not a good example to look at it. That's okay. So I only have this now. Let me remove this. Okay, so if we look at, give me a second, so we have that. Okay, so the number here, irrelevant. Okay, technically, this statistic F follows a distribution. Okay, and this distribution depends on the degrees of freedom, which are depend on the amount of cells that you have in your data. I'd say to you that's irrelevant. The point is, you have a test that it's a test of the goodness of the fit. Okay, it's not related to the fact that it's an F. Okay, so you have an F that it's a test of the goodness of the fit. This result is whatever, in this case 424, but could be any number. The important bit is the probability of observing that number and you being wrong. Okay, so you being wrong here means there being no good linear explanation for your data. So you go out and say, hey, there is a linear model that describes well my data, okay? And I tell you, okay, but what are the chances of that being true? Well, I don't know what are the chances of that being true, but the chances of that being false, given this result, are smaller than 0.01. So you're probably right. that is interpretation. Okay. So this number, you don't care about it particularly. What do you care about is the probability associated to that number being observed and you being wrong, which is very low. Yeah. Like, well, I didn't hear anything, but I hope it's yeah. Yeah. Okay. I would ask. So, do you have questions? I would like to answer your questions, and if not, we can make maybe a 10-minute break. Up to you. All right. So, if there are no more questions about this, if everyone is okay with it, let's do a 10-minute break, and we come back with new energy. See you now, guys.